So far, we've discussed limits of a single function at a particular point. In this video, we'll talk about what you can do if you know the limit of multiple functions at the same point. So here we have the limit of f of x as x approaches a. And let's say that's equal to 5. And then over here, we have the limit of g of x at the same point a. And let's say that we know that that limit equals 3. And then we can talk about combinations of the two functions. For instance, we could take f of x plus g of x, and we can try to find the limit of this sum at the same point, so as x approaches a. And it turns out that as x approaches a, the limit of the sum is equal to the sum of the two limits. In other words, 5 plus 3, or 8. Let's go ahead and justify this. We're looking at what happens as x approaches a. And we know that f of x is approaching 5. Now, that doesn't mean that f of x ever actually equals 5, but it'll be off by just some small error. So we can write f of x equals 5 plus this little e, and e stands just for small error. And this is actually the Greek letter epsilon. And I'm going to call it epsilon sub 1, since we're going to have another one for g. G of x we know is going to be 3 plus some small error of its own, which I am going to call epsilon sub 2. And we know that as x tends to a, these small errors, epsilon 1, epsilon 2, they're going to be getting smaller and smaller, going to 0. Meanwhile, f of x plus g of x, just add this, and it'll be 8 plus epsilon 1 plus epsilon 2. So it'll be off from 8 by epsilon 1 plus epsilon 2. But of course, both epsilon 1 and epsilon 2, those are our small errors. They're getting really, really, really tiny as x gets close to a. So their sum is also going to get really small. And that means that this error goes to 0, and the limit of f plus g is going to be 8, just as I promised. And this works in general as well. So I'll erase this first, and then the general statement is if the limit as x approaches a of f of x equals some number L, and the limit as x approaches a of g of x equals some number m, then the limit as x approaches a of the sum f of x plus g of x is L plus m. So the limit of the sum is the sum of the limits. And this will work with one-sided limits as well, as long as you're coming in from the same side on all three limits. For instance, x approaches a from the right, a from the right, a from the right, like that. Okay? This is called the limit law for addition. And a similar thing will hold for subtraction of functions. If we have these limits of f and g, then the limit as x approaches a of the difference f of x minus g of x will be the difference of the two limits, L minus m. Same for multiplication. The limit as x approaches a of the product f of x times g of x will be the product of the two limits, L times m. So those are the limit laws for subtraction and multiplication. There is a limit law for division, but it's a bit more complicated. If you take the limit as x approaches a of the quotient f of x over g of x, it will be L over m if the bottom limit m is not 0. So far, so good. But if m does equal 0, then things become really interesting. I'm not going to say exactly what happens just yet, but it's so interesting and so important to calculus that we're going to save that discussion for a whole other section. So stay tuned.